that you
the link.
tried the
Just to first
thing that I just asked. I've seen some of the solutions. Let's add to that one and let's talk about user-defined objects or the classes. If you want to access the classes or use the link to access something from the class data, like the objects data. So let's start talking about that now. And for that, again, we'll just create a quick class and we try to run the class. So let's take out button. So that's called user-defined objects. Like classes UD objects. So this is ideal UD objects. Right? Okay, so let's maybe add a class to this one. We might use that class for other purposes as well. Let's call it department class. And again, we'll make it public and we'll just do a basic thing here. Just let's keep it very simple to properties here and then we'll just use them.
Bless you. Thank you. Nicole, why do you initialize an empty string to the label? Is that why the label doesn't show up when you first do it? Because if you don't do that, then text and the label will show up next to the very first thing in there. Oh, for real? Like, for example, watch back.
The default text is.
Yeah, the default text will be there. So that will still be there. Well, I guess not that one because it's got regex. But this one.
Okay. That should make sense.
Let's see. So here if you see that this department over here, the list we are maintaining, again it's of var type, variable type. And if you see that we are printing out from the variable type, so it's an object coming up. Since this is a user defined object, so it just comes up with its own values, and we're going to take out the value for each record by using this DEPT, like which is one value out of the list. So list, basically this query now is querying an object of class, like object list of the class type objects. And then again, for the printing time also, we are just still taking that as an object, as a var. Now that's again, if you remember that we talked about that boxing and boxing string, that here our object is object based. Typically, we don't need to convert that, we don't need to work on that, but we know that this object has certain properties that we can just access from here. And if you want to access that, we'll have to just access that particular object thing. So that's like, you know, very much like, you know, if you have a classes or something, we want to search. And now, as we have done previously, that this query, that line number 59, this query that we have written down, this can have a lots of other, like, you know, options that we want to select, because it would be bringing out the objects. So we can test that one. So for example, as you remember that we have just already talked about that any departments with a specific features, maybe specific ID, or maybe specific, maybe some names, or you want to search, you have a list of, you know, it might be departments, might not be that long, but there are employees, that employees list is there, and we want to just, you know, query a list out of that employee list. We can always do that by specifically specifying that one. So can you just right now quickly try that one out over here, just applying a query condition to the object as well. How we can just, you know, apply the query condition to the object. Can you just find out, for example, you know, if I give a query like, you know, an ID of department, it just brings up that department that has that particular ID. So maybe rather than coming as a list, it would be coming as, for example, if I want to just find the finance department, which is at one ID, so how my query would go on. And again, in the same way, if I want to go for a particular name or particular department of the name, how my query will go about that one. So can you just, you know, try that out, how to incorporate those changes, as we have done in the strings as well. So for strings, what we are doing, we are using the string functions, the default string functions. Here also we'll use the string functions, but since it's an object, so we'll have to just look into the fields of that one. You know, the field, typically fields, which field I want to access. So from here, when you are just, you know, finding out from the departments, you might want to go into the list and find out that typical value that we want to access. So finding out particular ID of department, by finding out, maybe sometimes you'll be taking input from the user and then passing that over here. You know, the query that we are writing, the link query, and this link query will be just trying to find that out and accessing that particular record. So how did you access this one?
I just took wherever the department ID is an odd number, just select those.
So how did you do that? Which one you changed in this query?
My query is like for the index, I mean the list, where d.department ID modulus 2 equals 1.
Okay.
Select.
So what is the condition that you are applying that, right?
Mm.
So we need to introduce a where as well, right? Where is introduced everywhere where you are just put into condition, and that condition will be typically, you know, used in that one. So that's for the department purpose. Let's go back to our slides and look at some of the more. So we have just looked at some of the aspects of that one. We'll look at, you know, as I told you, different types of data that we have. Let's start from this slide. So query expressions. What are query expressions? A query expression is essentially a link query presented in a format that is reminiscent of SQL, featuring familiar query properties such as select, where, and order by. You remember I've told you that those who have looked at the SQL queries, they will find it they are very near to that one. They are very near to those queries. Typically, a query expression begins with the word from, but here it starts with the from. But you know what is the difference between the SQL then? There the query starts with select. Usually the reading query, like the get query over there, it always starts with select keyword, or maybe update keyword, or maybe delete keyword. And here, like contrary to that, here we have this from keyword that starts. So again, it's a bit upside down, you know, upside down in that way. Utilize standard link query operators. The namespace system.query is automatically imported. So again, we don't know, we might not have used that, but system.query is a dependency or a namespace that is automatically being imported with that. These expressions are constructed using a declarative query syntax introduced in C# 3.0. So it was introduced in 3.0 C# and they are used. Now there is something called stored procedure. They have quite a similar purpose in databases. You will see stored procedures in databases. We write a procedure and that procedure runs to the database and tries to extract information or something. But see what is the difference. There is an array of differences existing between link and stored procedures. These differences are mentioned here. Stored procedures are much faster than a link query as they follow an expected execution plan. This is a very important point when you'll study SQL. You will see that execution plan is very important. Sometimes some queries will look more appropriate, more efficient, but they will be following, bad execution plan. That's called bad execution plan or good execution plan. So queries, when they are executing, there is an execution plan that comes out. And if a query is following an efficient query execution plan, it would be much faster than the other, in that term. So stored procedures are faster that way because they have the structured, again, they have a structured expected plan because they have followed. It is easy to avoid runtime errors while executing a link query then in comparison to stored procedure, as the former has Visual Studio's IntelliSense support as well as full type checking during the compilation time. So, the IntelliSense support, sometimes, of course, most of the times it's quite helpful. But at times it might become, while you would have experienced that while you are typing that, while you're using that, at times it produces the code that might not be feasible in that. So runtime errors that might occur because of some maybe IntelliSensing of our Visual Studio, that might be a problem. So link allows debugging by making use of .NET Debugger, which is not in the case of stored procedure. Debugging is important. So link will allow us the debugger of our Visual Studio. When we want to test some particular points, what we do is that we just point that out. So link, it will allow us to use the same debugger, that we look at different variable states during the execution, which variable where we are typically going, having a break of our software. So that typically is link will allow us to use that. Link offers support for multiple databases in contrast to stored procedures, where it is essential to rewrite the code for the drivers types of databases. So again, this is one advantage that we have already discussed, that it gives us the ability to talk to different databases, to talk to different languages. So it will offer support for multiple data in terms of databases as well. It will be available for multiple databases. We can talk to different databases. While as when you talk about a stored procedure, it has to be specifically aligned for that particular language, and that is one that we have just already talked about. Deployment of link-based solution is easy and simple in comparison to the deployment of a set of stored procedures. So one way or other, it's generally the cost of execution at times will be much more efficient, or much more the solution that will be created by the queries will have much much less complexity as per against the functions or the stored procedures. So that also one way or other that represents here. Link presents there are lots of advantages. Its primary strength lying in its powerful expressiveness, enabling developers to express queries declaratively. Here are some additional benefits of link. So now that it has a lots of them, but some of them are syntax highlighting in link aids in identifying mistakes during the design time, enhancing code quality. So again, that's that probably something that comes up with the stored procedures as well, because here we are writing that in our Visual Studio environment, so it might be far better in finding out the compilation time errors when we are writing the code. The inclusion of IntelliSense facilitates the creation of more accurate queries with that. So again, IntelliSense has both ways, both words, So it might be when we are writing queries, and we see that IntelliSense is now very intelligent of this Visual Studio code. It really predicts a lot of code by itself and saves a lot of time. It accelerates the coding process, leading to significant reductions in development time. Integration within the C# language makes debugging easier and more. We have talked about Link's hierarchical feature allows a straightforward view of relationships between tables, enabling quick comparison. So again, here this point, another point is it will make much more sense when we know what is the relationship between the tables. This relational database concept that we talk about, when we create this SQL databases, there is a relational diagram that is made behind that really shows the relationship between the tables. And at times that might be a complex relationship if you know about the primary key and foreign key and things like that. So tables start getting into mingling into each other because there are lots of links. So but we'll see one maybe example of links. There's a hierarchical feature, expression tree it is called. So if you use the link tree, that would be much more easier to understand, and it would be a top to down tree, maybe, you know, in the tree sequence that we have used. More advantages: by offering a unified foundation, Link allows developers to use a single syntax, and again, that's very obvious, single syntax for multiple sources. Write one syntax for multiple sources, you don't need to change the source, and the code will be same. Its extensibility permits the utilization of its querying capabilities with new types of data sources. So again, it's still, you know, the data sources, as I told you, they stopped at XML. So keep on, the data sources might keep on coming for the databases as well. So databases are also in a huge transition from, you know, from SQL to NoSQL, and from being, you know, maybe small scale, not a small scale in that sense, but now the data is going huge in that way, like, you know, producing millions of terabytes of data in few you know, sometimes. So that's really making it. So Link has the extensibility to adjust according to the maybe syntax of new languages. If something new is introduced as a data source, Link has this capability of scalability to adjust itself according to the requirement. So complex problems can be broken down into concise, easy to debug queries when using Link. So we can write small queries for that particular one and try to, you know, divide and conquer rule we will be using. Link provides simple data transformations, making it effortless to convert one data type to another, such as converting SQL data to XML data. So the data transformations are also easier with using the Link, because, you know, we don't have to go from one language to the other. Rather, we are going underlying logic is changed, and like Link query is basically working for us. Now, here comes the one that we have used, but we'll just see one more example related to that. Link to objects. So we see that there are multiple link queries with multiple elements. So one of them is with the objects, and we'll see the example as we have seen one IEnumerable example. So queries in link to objects primarily return variables of type IEnumerable. So did we see the first example, IEnumerable integers? So it returns primarily the IEnumerable of any type which we are using. In essence, Link to objects introduces a fresh approach to handling collections, replacing the need for a lengthy and complex coding such as for each loops to retrieve data from collections. Instead, it enables developers to write declarative code that precisely describes the desired data to be retrieved. So again, here what they're saying, like, we could write this logic in the for each loop as well. You know, usually we do that. We go in the for each loop and write our whole logic over there. But what it says that we can, so right now what we are doing, if you see the logic of extracting value is before that. For each is just traversing through that list and producing the output. But if you look at that, the cost of finding the value is not coming inside the for each. And as I have just maybe talked about before as well, these algorithms, you know, their cost of execution changes big times when there are loops and things like that, you know, when there are loops being running. So loop typically adds a lot of execution time to algorithm. And I told you, as that's the reason why Google will keep on looking for, you know, the ways to lessen down the time of execution of the query and returning the result. Do you see that always you will find the time in the seconds? And that same goes with the SQL queries. When we write queries, as I told you, execution plan before. So execution plan is very important, and as I said, some queries they would generally will be considered more efficient, but their execution plan is bad. So they would be taking or eating up much more time than the other one, their alternatives, right? So anyhow, but in general, if you talk about that one, that you know, the execution time is very, very important. And when we are not introducing the logic of searching in the loops, it means that we are taking a good burden out of the looping structure, and thus we are not, you know, even though loop will be creating multiple statements, but the cost of execution will be much smaller, because now loop will be only traversing the list. It is not trying to go somewhere and find something, but rather it is trying to do what? It's trying to just go and traverse them. Okay, the advantages of link to objects over the traditional for each loops are numerous. It offers enhanced readability, powerful filtering capabilities, the ability to group data, and improved ordering with minimal coding effort. Additionally, link queries are more concise and can be easily adapted to work with other data sources. That is something that we have already discussed. Okay, so we have seen this object example, and again I enumerable example, that it would be returning us the I enumerable thing. Let's see one more example of this one, and then we move to the lambda thing, and we'll see some lambda examples as well over there. Okay.
Sweaty. Get my mic wet.
So I'm just calling it objects 2 because it should 1 to 1. Or rather, because we have seen that, so rather let's put that. I'll just put that for lambda because I'm just, that one example will cover both. And I'll just show that, because let's discuss that, because that would be missing. So link with lambda expressions, I just want to, because we have seen that example. So see here, we'll just look at this lambda example. The term lambda expression is inspired by lambda calculus, a mathematical notation. We've just seen that. Lambda expressions are served as the executable part of a link query, dynamically translating logic at runtime for seamless interaction with the data source. So again, it's the one-liner functions that have the fast capability to just run and interact with any of the source, so to speak, and it might be data source in that. Now, there's the application of lambda expressions extends beyond link. They find very use in various other contexts as well. Now, let's see expressions, lambda expressions, how they are made. These expressions are expressed by the following. So they're lambda function that uses lambda expressions, or we can just use lambda expressions as well. So input parameters, and then the expression or statement block. So we can have this y tends to, or having this y multiplied by the above expression specifies a parameter named y, and the value of y is squared. However, it is not possible to execute a lambda expression in this form. So we cannot execute that. We might need something. But let's talk about this lambda expression before that lambda function even. We'll be just talking about the lambda function also, but that would be later on. Let's see that with lambda expressions.
Basically like callback, right? JavaScript almost. Kind of.
I don't know.
Because you're returning whatever you wanted to return.
Yeah, but callback is a different thing.
Isn't
It's
you're
a
running
async.
a function, but yeah, it's async.
Yeah. This one is a sync one.
That's,
So we define delegate here.
Cool. Your CPA, right?
Hmm?
Your CPA? Or your CPA?